In section 6.1, part 3, we introduced the final amount of vocabulary that we need. So we're going to introduce the idea of union. And you may recognize these terms from your algebra classes, but a union simply means everything in both sets. And we'll do an example here in just a minute once we get the vocabulary down. It's everything in both sets. I want to comment that the key word that indicates you have a union is the word or. The symbol or notation for a union looks like a U. And if you did anything in algebra with interval notation, you've used this U before. We also have the idea of an intersection. So, and this is the elements in common. So it's the overlap. The elements in common to both sets. So I like to think of it as the overlap. So think of an intersection of two streets. The actual intersection is the place right in the middle where the two streets cross. The key word for an intersection is the word and the symbol for an intersection is an upside down U. It looks like an N without the tail on it. So, and the easiest way to remember the key words is that or is shorter than and union is shorter than intersection. So short word with short word, long word with long word. So intersection and union. Okay, and then finally, the other terminology that we need is the idea of the complement. The complement of a set. And this simply means that everything in the universe outside of that set, outside of that set. The notation that we're going to use for a complement is a little c, and it'll be written as an exponent. So we would write it as the complement of A would be A with a C on it. So that little c means the idea of complement. So let's do another example and introduce or use these notations to get you used to it. This time we're going to let A be the set 1, 2, 3. We're going to let B equal the set 3, 4. And then finally we're going to let U equal the set 1, 2, 3, 4, 5, 6. That's a 30. Okay, so there's our universal set. This is every number that's under consideration. And then we have two subsets of our universal set, a set A and a set B. So the very first question asks us to list the elements in each set, and they're asking for A union B. And so what this means is everything in both A and B. Everything in A or B, trying to use that keyword. So for us, this is going to be equal to, well, I would have the 1, the 2, the 3. I don't need to list the 3 twice, even though it appears in both, because we never list repeated elements, and then the 4. So that's everything that's in A or B together. Part B is going to ask for A intersect B. So this is the overlap. This is whatever they have in common. And so for us, the elements that are in common are the 3. So the intersection of our two sets is the set 3. Part C is asking for A complement. So this is everything outside of A. Everything in U outside of A. So when I take a look at A, it has the 1, the 2, and the 3. Well, the universe also contains a 4, a 5, and a 6 that are not in A. So what's outside of A is that 4, 5, 6. So the complement to A is 4, 5, and 6. Part D is asking us for A complement unioned with B. A complement unioned with B. Well, I'm going to use A complement that I just found, and I'm going to union that with B. Union means everything. So I'm going to list everything that's in A complement and everything that's in B all together. So that would give me the 3, the 4, the 5, and the 6. So everything that was in A complement, everything that's in B, written as a single set. E on that example says, how about A complement intersected with B? So intersection is the overlap. It's what they have in common. So I look at A complement and I look at B. This time I see the only thing that's listed in both of those sets is the 4. So this set would be the 4. Okay, our next example goes back to some true-false questions. The goal here is just to have you become comfortable with the notation because it's new and we need it. I'm going to get out a new marker because that one's looking a little pale. Sorry about that. Okay, so our next example, we want to determine whether the statement is true or false, and explain why it's true or explain why it's false. Let's use examples to do that. So the first statement says, if, this is A union B is equal to A. So if A union B is equal to A, then A is a subset of B. So if A union B is equal to A, then A is a subset of B. Well, let's come in and do an example just to see whether or not it's true or false. So I'm just going to make up some sets. Let's let A be 1, 2, 3. Let's let B, and again, I'm looking for a union here. So I want to make sure that the result is A. So B is not going to have anything outside of A. Let's just have it be 2. So if I union them, if I add this one and this one together into a single set, I get A. So the first part of this is true. So is A a subset of B? Well, no, because A contains things that are not in B. So this is false. And we can see with my example that it is false. Part B on that example says, if A equals B, then A is a subset of B. And we know that's true already. A and B are the same, then they're subsets of each other. So that one's definitely true. Part C, if A is a subset of B, then automatically A is a proper subset of B. So again, this is proper. This one's just subset. Well, this may be true, but it's not always true. If we reverse our order of what we did up there, let's pick 2 new sets. Let's let A be the set X, Y. Let's let B be the set X, Y, Z. So we can see that A is a subset of B, and A is a proper subset of B. That's true, right? But what if we let A be the set X, Y, Z, and B also be the set X, Y, Z? So the first condition is still true. A is a subset of B, but it's not a proper subset because they're equal to each other. So it's not true if they're equal. So false if A equals B. Okay, the next one, part D, says if A is a proper subset of B. Sometimes I get too enthusiastic about my symbols. If A is a proper subset of B, then A is a subset of B. Well, that one's true. Because if A is totally contained in B, then it's going to be a subset of B. And again, remember this one says that A is smaller than B, so then A has to be contained in B. So we can see that one's true. And E on that one says that if A is a subset of B, then A equals B. No, we can already see that that's not true with this example. It's already on the board. We know that A was a subset of B in this example, but they're not equal to each other. So that one is false. So when you're doing these on the homework, one of the things to do is just to make up a set. See if you can make up a set that makes it false or not true.